In the field of science, there are 7 hats or job descriptions people can choose.
A theorist like Einstein.
A scientist, like Eddington.
An engineer like Musk.
A technician, like Sean.
A philosopher like Sir Bacon.
A teacher, like the physics girl.
So many questions!
Or a manager, also like Musk, showing that it isn't unusual to wear more than one hat.
For example, Newton, that created Newtonian physics, also designed a telescope, a device that would prove one of his own laws of physics to be incomplete. A technician operating a telescope logged several transits of Mercury across the Sun. Those records were turned over to a scientist, Leverrier, that had gained prior fame when he used Newton's theory of gravity to predict the exact location of an unseen dwarf planet, leading to the remarkable discovery of Pluto that very evening. But when Leverrier tested the observations of Mercury against Newton's theory of gravity, the predictions were wrong. Newton's theory of gravity was proven to be incomplete. That's how the field of science works. Theorists theorize. Scientists compare predictions to facts to determine if the theory is supported or wrong.
This happens all the time. Theory proven to be wrong or incomplete, which speeds up the scientific method. That led to 2 competing theories.
Because the anomaly was found by Leverrier, most theorists jumped on the missing planet theory. The planet Vulcan was born. Yes, Spock and Leverrier even had similar personalities, highly intelligent, logical, and efficient. But not all theorists were fooled.
A young theoretical physicist, Einstein, working in a patent office, became intrigued by the discrepancy. He used his powerful imagination to come up with an alternative idea. What if the gravity of the sun was warping space? Would Mercury follow that path like a boat caught in a gentle whirlpool?
Observation, check. Why, check. Theory, check. But consensus that is critical for a theorist was not complete. Until there is a consensus, the theory isn't stable and may not warrant the time and resources required for a scientist to test it. But Einstein published, in error. Fortunately for Einstein, World War I postponed the planned test of his theory, giving Einstein time to get consensus, correct the math errors, and publish correctly.
In law and science, recusal is followed. A theorist cannot be the one to officially test their own theory. Tests are independently designed, tested, and analyzed by scientists trained in the last 5 steps of the scientific method.
Eddington volunteered, well trained in the testing side of the scientific method, and was one of the few that understood the symbolic math of Einstein. He used a total eclipse to measure how much starlight bent when passing by the sun. He photographed and measured how much the light bent, and then compared that to the prediction from Einstein's theory.
Eddington would complete the remaining 5 steps of the scientific method and deliver the good news to Einstein.
When science follows the scientific method, humanity receives huge benefits, like accurate GPS thanks to Einstein and Eddington. So, what happens when a field of science can't follow the scientific method?
Consider the dilemma of theoretical physicist Newton in 1687, who theorized how gravity worked on mass. If the mass of light was 0, no effect. If equivalent mass mattered, then it would bend a little. The first 4 steps of the scientific method were done, but impossible to test without a camera and the mass of light. So, for more than 200 years, the theory would go untested.
Climate science had the same problem. In 1896, Arrhenius theorized that a doubling of CO2 would raise global temperatures 6 degrees, but impossible to test, because measurements of global temperatures wouldn't exist for another 100 years. And when the theory was finally tested in 2010, the theory wasn't found to be wrong. Just like Newton's case, man-made climate theory was found to be incomplete. Those tests are conducted about every year or 2 and are more enlightening and confirming each time.
CO2 generally warms in desert biospheres, and generally cools in farmland, grassland, and forest biospheres. The rise in CO2 is greening Earth, and since 1974, is slowing down the natural cyclic thermal recovery from the horrific death rates during the Little Ice Age. With confirmation from 7 independent science teams, there is no doubt about the findings. But the question remains, what theory explains those facts of nature? NASA has a theory. Google NASA Green Earth.
You deserve the truth. I hope you found that very interesting.